Have you noticed something about all of the questions that we've done so far? Every one of the questions, the leading coefficient has been a 1. But what happens if the leading coefficient isn't 1? Like, for example, right here. Look, I give you a 5. Does that mean we abandon everything that we've learned so far? No, of course not. But we have to introduce a new zero theorem. And it's called the rational zero theorem. Now, wait a second. Watch this. If a polynomial is an integral polynomial, these are all integers, right? Okay? It may have a rational zero of a over b. What's a over b mean? Real simple. Here it is right here. Look, a works out to be all of the factors of the constant term. B works out to be all of the factors of the leading coefficient. So take the factors of the constant term divided by the factors of the leading coefficient, and you'll get all the potential factors of that polynomial. You're probably going, I don't get it. Let me show you. It's really, really simple. Look, watch this. Let me get rid of this so it doesn't confuse us. Okay, here, check it out. Watch. It says right off the bat, find me the factors of the constant term. Well, the constant term is minus 9. Give me the factors. Sure, plus or minus 1, plus or minus 3, and plus or minus 9. Well, that's really easy to do. Give me the factors now of the leading coefficient. The leading coefficient is 5. Okay, so if the leading coefficient is 5, I got plus or minus 1, and oh, how nice, plus or minus 5. Now, what is the list of the potential zeros? Okay, so take all of these factors, divide it by all of these factors. Look at every possible combination you can get. What do I mean by this? Okay, watch. Real simple. Watch. Start with this one. There's the coefficient. I should say there's the constant term. Divide it by the coefficient. So I can have plus or minus 1 over plus or minus 1. Okay, so a potential 0 then, right? So let's list our potentials in here, okay, is plus or minus 1. Well, that was easy. Now, take a look at this plus or minus 1 again, since we've done it. It's got to be over plus or minus 5. Uh-oh, plus or minus 1 over plus or minus 5 now. So in other words, one of the potential zeros could be a rational number of plus or minus 1/5. Oh, now you get it? Yeah, that's not so tough. Let's try another one. Look, we can go. Now that we've exhausted all the possibles with that one, let's do this one. Your next one could be plus or minus 3 over, guess who? Yeah, this guy again, plus or minus 1. Well, yeah, okay, that was tough. Okay, but look at this. You can have plus or minus 3 now over plus or minus 5. Ooh, now we're getting interesting. Over plus or minus 5. So in other words, plus or minus 3/5. That could be a potential root. Oh, neat. Interesting. Okay, so we've exhausted 3. Let's go over to 9 now. Okay, plus or minus 9 over plus or minus 1. Okay, because that's this first one again. Well, that's plus or minus 9. That's easy enough to do. And then our last potential could be plus or minus 9 over plus or minus 5. Plus or minus 9 over plus or minus 5. Okay, so that leaves us plus or minus 9 over 5. Okay, so you have to try every single one of these potentials to see if it actually gives you a 0 or not. Oh my God, yeah, that's going to take forever and a day, isn't it? Well, yeah, but you know what I want to do? I want to try this guy right now. I want to try this guy right now because that's our first one. So I want to try P at 1/5. Now, could you imagine putting that into this formula? This is going to be just awful. Look at this formula. Look at this equation. Oh my goodness. 5x cubed minus 51x squared plus 55x minus 9. Well, you know what you can do? Let's just put this into our calculator. Let's put this into our calculator. Just like we did before, I'm going to graph it. Okay, watch. Bring up my calculator. Boom. I already have my equation in there. I'm going to hit graph. I'm going to get some sort of funky thing that looks like that we don't even know what the heck that means yet. But check this out. Normally, if I used a table, right, it would give me something like that. But if you noticed, your table doesn't go and do 1/5. It doesn't do rational numbers very well. But here's something that you can try. You can go second calc, and look what you got here. You've got value. And it says, what's your x value? I want to try 1/5. Check it out. It's a 0. And it even blinks on the graph telling you it is a 0. So guess what? 1/5 works. That's going to give you 0. Lovely, 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 lovely. So that means that if you go x equals to 1/5, this should synthetically divide out quite nicely. Well, okay, so let's use that. 1/5, 5, minus 51, 55, and minus 9. Oh my God, yeah. This is going to be really bad. This has to give us 0. Otherwise, 1/5, what we did in the calculator was wrong. Okay, so how do we do this? Drop the 5. Okay, 5 times 1/5. Oh, 5 times 1/5 is just 1. That's easy. 1 plus a negative 51 is negative 50. Oh, look at this. Negative 50 times 1/5. That's easy too. That gives you negative 10. That gives you 45 here. 45 times 1/5 is 9. Oh my, it worked. So you got 0, you got x, and you got x squared. But remember, when you're factoring this, 5x squared minus 50x plus 45 all equals to 0 because you're trying to figure out the factors. So you can now, look at this, you can actually divide out that 1/5. So this, if you divide out that 5 all the way through this, that 1/5 idea, x squared becomes minus 10x plus 9 equals to 0. Do you have to do this? Yes. Yes, you have to, because that's kind of the drawback of synthetic division. Right? Synthetic division wants this number up front to be 1. So you'll have to simplify this polynomial in order to make it work. And then check this out. You can easily do this factoring in your head. PSA it. A product of 9, a sum of minus 10. So this is going to be x minus 9, x minus 1. Along with this factor here, we haven't put it into integral form yet. Ah, man, what a pain. Okay, so what? X equals to 1/5 times each side by 5, right? That gives you 5x equals to, those cancel, equal to 1. Bring the 1 over, you got 5x minus 1. There's your other factor. And lo and behold, I just finished factoring this thing. So now look at the power you have. You have zero theorem. You have factor theorem. You have integral theorem. You have rational zero theorem. Oh my goodness, this makes you incredibly powerful factoring mathematician. Wow.